Welcome to episode 2 of our ComfyUI tutorial series. In this video, I will show you the basics of nodes and workflows, helping you get started with building your own projects. Even if you don't plan to create your own workflows, maybe you download workflows from others and need to make changes. So it can be useful to have an idea of how things work. In episode 1, I demonstrated how to install and generate your first image using Stable Diffusion. If you haven't installed ComfyUI or downloaded the model yet, please check out that episode first. This is a basic Stable Diffusion workflow that can generate an image from text, often referred to as text-to-image. To help you understand how it works more easily, I'll provide a simple analogy that will give you an idea of why it requires numerous nodes and steps to function properly. I added some notes around the nodes to make it easier. Now, imagine you're designing a custom cake at a bakery. First, you choose a skilled baker, the model, who specializes in the type of cake you want. In this case, our baker is the Juggernaut model. Then you give the baker detailed instructions on what you want in the cake, such as vanilla flavor, strawberries, and whipped cream. This is called the positive prompt. And what to avoid, like nuts, chocolate, this is called the negative prompt. The baker starts preparing the cake by mixing the ingredients and baking it. This is what the K-sampler node does. Then you decide on the size of the cake, perhaps an 8-inch round cake. This is where we use the empty latent image node, where we specify the width and height using pixels. Once the cake is baked, the baker decorates it and prepares it for serving. In this workflow, we use the VAE decode node for that step. Finally, you take the completed cake home and display it on your dining table. We use the save image node for that step. Did this analogy help you understand better the workflow? Let's review it quickly. We select the baker. You give the baker detailed instructions on what you want in the cake and what to avoid. The baker starts preparing the cake by mixing the ingredients and baking it. You decide on the size of the cake. Once the cake is baked, the baker decorates it and prepares it for serving. Finally, you take the completed cake home and display it on your dining table. Let's talk a little bit about the interface. The queue prompt button adds the current workflow to the queue, which prepares your setup for image generation. It's like hitting start on a task list. By checking extra options, it reveals more advanced settings for generating images, such as the number of images to create at once, the batch count, or automatic queuing when parameters change. The save button saves the current workflow so you can load it later. It's like saving a document on your computer. The load button loads a previously saved workflow, restoring it to your current session. This is useful for reusing workflows. The refresh button updates or reloads the current view or settings, ensuring you see the most recent changes. The clear button clears the current workflow, resetting it to a blank state. The load default button loads the default settings, returning the interface to its original state. The reset view button resets the layout or arrangement of the interface elements to their default positions. The manager button opens the ComfyUI Manager, which is a management interface for detailed control over your project's settings and custom nodes. The share button allows you to share the current project or workflow with others on different websites. So save your current workflow by clicking save, give it a name, and store it somewhere on your drive. Then click the clear button to remove everything from the screen and start fresh. The area where you add nodes in ComfyUI is commonly referred to as the canvas or node canvas. This is the main workspace where you can create, connect, and manage various nodes to build your workflows. You can add a new node by either double-clicking. For example, you can search for load and select load checkpoint, which will add that node to the canvas. You can left-click on it and move it around. And the second option is to right-click on the canvas, then go to Add Node, and from the list, select it. From the loaders category, I can select the same node, Load Checkpoint. To select different nodes, simply click on them. If you press the Alt button and then left-click and drag, it will drag a copy of that node. Alternatively, you can use Control plus C for copy and Control plus V for paste. If you right-click on a node, you have access to more options and settings. You can also remove the node using the remove option or simply press the delete key while the node is selected. Sometimes you need to resize a node to make it look better. You can do this by dragging from the bottom right corner. Resizing from other corners won't work. Only that corner will allow you to resize. Here you have the node name, and in front of it there is a small circle. When you click on it, it will make the node smaller. This action is often referred to as collapsing the node. Collapsing a node reduces it to a more compact form, which helps in managing and organizing the workspace more efficiently, especially when dealing with complex workflows. Here are also some shortcuts you can use to select nodes. Remember these 3 control keys: Alt, Control, and Shift. Knowing these 3 keys is usually sufficient for most software out there. If one key doesn't work, try another. That is what I do. Since I cannot remember all the shortcuts, many programs have hidden features accessible through these keys. To select a single node, simply click on it. If you want to move the node to a different position, click on the node and drag it to the desired location. To select multiple nodes, hold down the Shift key and click on each node you want to select individually. You can also select multiple nodes by holding down the Control key and then dragging to create a selection box that encompasses all the nodes you want to select. Release the mouse button to select all nodes within the box. Once multiple nodes are selected, hold down the Shift key, then click and drag any of the selected nodes to move all selected nodes together. Let's clear the canvas and let me show you a few more things about the nodes. I will add a few different nodes so I can explain what several key elements are composed of. We have the node name that identifies the function or operation of the node. For most nodes, you can guess what they do from their names. For example, if load is in the name, it probably loads something like a checkpoint model in this case. K-sampler may not be obvious from its name, but you can think of it as a family of samplers. To make it easier to remember, consider K-sampler as a key component. Save image does exactly what it says. It saves the image to your computer automatically. Then you have the inputs, connection points, where data or signals are received from other nodes. For example, K-sampler has many inputs. Load checkpoint doesn't have any inputs. And save image has one input called images. Next, there are the outputs, connection points, where data or signals are sent to other nodes. K-sampler has only one output named latent. Load checkpoint has 3 outputs, and save image doesn't have any outputs, so you cannot add more nodes after the image is saved. And then you have parameters or settings. These are configurable options within the node that control its behavior and processing. For example, K-sampler has settings like seed, steps, and CFG that you can adjust. For save image, you can change the prefix value of the image name so that it starts with whatever value you add there. By the way, you can move this menu from the top left corner where those tiny dots are located. The connections between nodes in ComfyUI are called links, but you can call them whatever you like: cables, spaghetti. These links enable data or signals to flow from the output of one node to the input of another, allowing for the creation of a functional workflow. So if I want to create a link between these 2 nodes, I look at the connection points that usually have the same name and color. For example, here, both nodes have connection points named model, and the color is purple. This allows me to drag from purple to purple. However, if I try to drag to a different color, it doesn't let me create the connection. So I will drag it to the purple connection point, and when I release the mouse, the connection is made. Now you can see the link has the same color as the connection points. Now, if you look at these 2 points, they may look similar, but in fact, one is yellow and the other is orange. Additionally, their names are clip and positive. Therefore, you cannot make a connection between these 2 different types of points. If you want an idea of what node you can place there, you can drag and release the mouse somewhere on the canvas. A menu will appear where you can add or search for a node. The menu also suggests nodes that you can select. For example, if I select the clip text encode node, it creates that node and connects it in one move. When you delete that node, the connection is also deleted. So the easiest way is to drag and release to get one of the suggested nodes or search for a node. With a little practice, you'll learn which nodes connect with each other. For example, with latent, I can get a VAE decode node. Then from the VAE decode node, I can connect the pink output with the VAE from load checkpoint and so on. As you can see, you cannot connect to nodes of other colors. To unlink or disconnect a link from a node, you simply click on the connection point and drag it away somewhere on the canvas. When you release the mouse, the link will be disconnected. You can also delete a link by left-clicking on the little circle that appears on the link, then choosing Delete. You can also right-click on a node and go to Colors, where you can pick different colors to differentiate nodes that are more important. Additionally, when you right-click, you can change the title of the node. For example, you can rename it to exactly describe what it does. You can also change the shape of the node to box, round, or card, a combination of both, or you can leave it at the default shape. Additionally, you can use the resize option to automatically adjust the node to a smaller form. Let's clear the workflow and start our text-to-image workflow for Stable Diffusion from scratch. First, let's start by loading our model. We'll use the load checkpoint node for this task. And this node is straightforward. It loads the pre-trained model, the checkpoint that we'll be using. In our case, we're using a model called Juggernaut X. You'll notice that this node has 3 outputs, model, clip, and VAE. These outputs will be useful shortly. Next, I'll add the K-sampler node. This node begins with random noise and gradually turns it into a clear image by following specific instructions and settings, such as the number of steps and how strongly the instructions guide the process. This helps create a final, high-quality image. I will create a link between these 2 nodes, connecting the output from the model output of the load checkpoint node to the model input of the K-sampler node. You see here we have a clip output. CLIP stands for Contrastive Language Image Pre-training, which is a machine learning model that can interpret both images and their descriptions in natural language. It effectively bridges the gap between visual and textual data. To make an analogy for what CLIP does, it's like having a bilingual person who can understand both English and images. When they see an image, they form a mental summary. When they read a description, they also form a summary. They can then compare these summaries to see if they match. So if I drag and release, you can see in the suggested nodes the clip text encode option. If I select that, I now get the clip text encode prompt where we can input our text prompt. Now we need both a positive prompt and a negative prompt. I can either hold down Alt and drag a copy of the clip text encode node, or I can search for the node labeled prompt and add it. So now that we have both nodes, I will connect them to the load checkpoint node as well. You might wonder how the system distinguishes between the positive and negative prompts when both nodes look the same. In the K-sampler node, we have 2 inputs, one for positive prompt and another for negative prompt. By connecting each respective node to these inputs, the system understands which prompt is positive and which is negative. To quickly distinguish between nodes, many people assign colors to them. For example, we can color the positive prompt node in green and the negative prompt node in red. I will quickly add a positive prompt and a negative prompt so we can test them later when the workflow is ready. Now, each checkpoint has some recommended settings that we can use in the K-sampler, as you saw in the first episode when we got our settings from Civit AI, where I downloaded this model. I will add those settings here. So we have another input here called latent image. If we drag and release, we can see options like VAE, encode, or empty latent image. It took me a while to understand this, but everything that happens in the K-sampler node revolves around the latent space. Latent space represents hidden features of data in a simplified abstract form, making it easier for models to process. Everything that enters this space must be latent. If it's pixel data, we need to encode it first to convert it into this simplified form. So if I have a photo made from pixels, I cannot input it directly into the K-sampler. We need to use VAE encode first. We'll explore this process in another episode to create an image-to-image workflow. However, for text-to-image, we need an empty latent image. Even when using text to generate an image, the system still requires a placeholder image to work with and add noise on top to perform its task effectively. As you can see, we have width and height options here. Since we are using an SDXL model, we can create a larger image, such as a 1024 pixel image. So basically, most of the workflow is complete. We have the model, the prompts, and everything entering the case sampler, including the empty image that allows us to choose the size. Theoretically, the image exists in the latent space. We just need to extract it to view it. Remember, I mentioned that everything going into and out from the latent space must be either latent or converted to get pixels. Since we want to visualize the pixels, we use the load VAE decode node to extract the image from the latent space. A VAE variational autoencoder decode node is a component in machine learning models, especially in image processing, that transforms latent space representations back into their original visible form. Think of it like compressing and decompressing a file. The VAE encode node compresses the image into a compact form, latent space, and the VAE decode node decompresses it back to the original image. Now, I know from the model description that Juggernaut has VAE baked in, so I can simply connect the VAE from the decoder to the VAE from the load checkpoint node. But if you're using another model that requires a separate VAE file, you'll need to search for a node called load VAE. First, download the VAE and place it into your model folder, then into the VAE folder. After refreshing, select the model from the list and connect it to the VAE decode. In my case, I don't need this step, so I'll just connect it back to the model. Now, the final pixel image is here. We just need to save it. We could use a preview node if we want to preview the image first, and then save it with a right click. However, what I prefer to do is use a save image node. Now, that way, everything I generate is saved, and I can delete what I don't need later from the output folder. And that's it. Let's test it to see if it works by clicking on Q prompt. You'll notice each node gets a green outline when the flow is active in that area, which is a good sign. At the end, we'll have our generated image, all from a workflow created from scratch. Now, you might ask, why does it need so many components to make a simple image? I might ask you back, why do you need so many Lego pieces to build a castle? Consider a real-life example, a desktop PC. You have the unit itself, then you connect the power cable to the socket, connect the internet cable to the router, which is connected to other cables, and you also connect the mouse, monitor, and maybe a printer. All these components are necessary for everything to function properly. It's the same concept here. If you want control over the workflow, you need more components to build exactly what you want. I was curious about what's inside this latent image node, so I tried adding a preview image node. However, as you can see, we cannot connect them directly because the latent image is not pixel-based. Remember, we need to decode it first. So I will use the VAE decode node, and now I can connect the image to the preview image node. As you can see, I intentionally left the VAE input disconnected, so you could observe what happens when I run this workflow. When I cue the prompt, you'll notice the other nodes turn green, but this one remains red with a little circle around the VAE input, indicating this branch was interrupted here. And to fix it, we simply connect the VAE to VAE and try again. This is how the latent image looks. If I right-click on it, I can open the image in a new tab, and it appears as a gray with subtle purple hues, matching the size we defined in width and height. You can do the same for the generated image. With a right-click, you can open, save, or copy the image. I'll delete this part since we've seen what's there, and it's not particularly exciting. Let's change the width and height to generate a landscape ratio image. I'll adjust the values accordingly and also create a portrait ratio image. Remember to keep it around 1024 pixels. Larger images can capture more details, but if they're too big, you might encounter issues like duplicate heads or slower processing speed. When you're constructing a complex workflow, you might find it useful to visualize how all the nodes are connected. In such cases, a node called reroute can be very handy. Think of a reroute node like a cable organizer for your computer desk. Instead of having all your cables tangled and messy, the cable organizer reroute node helps you manage and direct each cable neatly to its destination. After completing the workflow, you can arrange it to fit better on your screen and make it more comfortable for you. For example, if you're used to interfaces like Automatic 1111 or Forge, you can organize it similarly if that's more convenient for you. In Forge, we have the Stable Diffusion checkpoint, which is equivalent to the Load checkpoint node in ComfyUI. Similarly, we have the positive and negative prompt nodes, which we can also arrange under the checkpoint if we prefer, and resize them accordingly. Then we have the sampling method steps, CFG settings, as well as the width and height parameters, all of which are also present in ComfyUI within the KSampler node. Additionally, there's the empty latent image node for setting the width and height. Let's remove these reroute nodes and concentrate on the VAE code. We can collapse the nodes we don't adjust settings for. I'll place it on top to mimic the layout in Forge and position the Save Image node on the right, similar to how the preview is arranged in Forge. If you don't like how the cables look in the background, you can go to Settings and choose a different link render mode, such as Straight, then close the settings. Next, I'll go to the Manager and click Restart. After the restart, the links are now straight. I'll try moving a node to see if the link stays straight. You can also group nodes together. Right-click on the canvas and select Add Group. I suggest resizing the group before moving it close to the nodes. Any node that touches or is within the group area will stick to that group like a super strong magnet that pulls in any node it gets close to, creating an organized bundle. Then I can arrange the items within that group as I like. I can also rename the group. Now I can move all items at once just by selecting the group instead of individual nodes. After playing around with it for a while, I managed to make it look like this. Now it almost resembles a regular interface and doesn't look so intimidating anymore, right? To change the links back to the default style, go to Settings, choose Spline, then Close. From the Manager, restart the interface, and voila, we have spaghetti links again. Now, there are custom nodes that can combine multiple nodes into one to make the interface even clearer, but that's for another episode. I hope you enjoyed this video. Please leave a like and a comment to support my channel. Thank you, and see you soon with a new episode.